Let's start with the basics. Historically speaking, the first security boundary is the physical computer. A boundary in this case must separate all local computer processes from the outside world. Once a computer is connected to a LAN and the internet, everything that is external to the machine is treated as untrusted. You probably experienced this multiple times launching a program from a network share. If a file is contained in a directory outside of your computer, trying to run it will be prompted with at least one pop-up warning stating that the file comes from an untrusted site and can be potentially harmful to your computer. Copying the file or downloading it from the internet using Windows Explorer or Internet Explorer won't automatically make it trusted. Both explorers mark such files as files that have crossed a security boundary. Even if they're currently stored on a C or D drive, all attempts to run them will display the same warning messages unless you check the files as trusted. We'll talk about that later. Protecting this data entails the control of all data transmissions. This can be implemented through the use of system firewalls. Firewalls have been controlling both incoming and outgoing traffic for some time already. The goal of establishing this boundary is not, however, securing a system against local attacks. The fact that a physical computer is a boundary doesn't mean that it can actually safeguard a system against people who have access to the computer's keyboard. Obstacle: this boundary is the most vital security-wise. Violating it involves the risk that a system is infected with an exploit that can be remotely executed or used to take over remote systems. This is the critical security level. If a breach of this boundary is detected, a software developer has to release a critical security patch. The second security boundary is the operating system. A single computer can feature more than one system. This technology is known as virtualization. It's hardly anything new, being first developed as an IBM solution in the 60s. Soon after the first system was virtualized, IBM Scientific Journal described the first exploit that crossed the boundaries set by an operating system. By exploiting a bug in the input-output control system, the exploit enabled the uncontrolled sending of data between virtualized operating systems. Virtualization is managed by a program or a service called a hypervisor. There's a particular assumption that arose around the model that makes each operating system a separate system with separate security, regardless of whether it's running on a physical computer or in an environment virtualized by a hypervisor. People believe that it's enough to secure the host system, update it, run an antivirus, pay attention to the files launched in the host. They think that these actions will also protect everything that has been virtualized in the host. This is a falsehood. All virtual systems require the same level of protection and security as a system that is running on a physical computer. Violating the security boundary set by a system entails an immediate release of an important security update. For Microsoft, this is a significant boundary that requires protection. We'll look at the third boundary a bit more closely. This boundary is defined by a user session. It relates to keeping the programs launched by a user on a system from accessing the programs launched by another user. This is critical, for example, in a terminal environment. If a user session did not define a security boundary, Windows wouldn't be able to operate as a terminal server. This means that if a company's president and an IT staff member would simultaneously connect to a server, they would both have control over each other's processes and be able to read the data modified by the other user. This shouldn't happen. How is the boundary implemented? Note that all processes launched by the user are run in the user session. We'll discover this in a moment. An operating system is still able to tell when a session process has been launched. System processes, for example, the services that are automatically run with the start of the system, have been separated to run inside their own sessions. Before this separation, they executed in the session of the first user who logged in. This constituted a critical breach of the boundary. Modern systems have amended this situation. All user processes are now tagged with a specific level of privileges. This permissions attachment means that the process can only be accessed by the user who launched it. Access control lists can be assigned not only to files, folders, and registry keys, but also to processes. Windows tags processes in such a way that only the user who launched them can access the process. To enforce data isolation, processes are bound to their own namespaces, to user namespaces. We've mentioned that this boundary is of key importance to a terminal server. There is a problem, however. If a user session really defined a security boundary, this would mean that an administrator doesn't have full control over his own computer since he can't interfere with the processes launched by other users. This shouldn't happen. A user session has been set to define a security boundary, but only for standard users. Users with raised permissions, for example administrators, are able to cross the boundary within the rules provided for the boundary. This is supported by Microsoft. Violating a user session boundary will also entail a release of an important security update.